Hello friends, welcome to Concept Clarity, your favorite channel on physics, and I'm your favorite physics teacher, Navito. So today's discussion is about electricity, or in other words, current electricity. And this is part of class 10 CBSE syllabus. So let us see what we are going to cover in electricity today. As part of electricity, we are going to have electricity discussed in two parts, part 1 and then part 2. In the first part, we're going to talk about, that is today's discussion, is going to be about electric current. We're going to see what is electric current, how is it defined, what are the equations. We're going to solve some problems as well. Then we're going to see about electric potential difference, how electric current flow is possible due to electric potential difference. And of course, we're going to solve some problems here as well. Then we're going to see Ohm's law. And then finally, we're going to see resistance and resistivity. And of course, we are also going to see what are the advantages of parallel and series connection as part of resistance itself. In the second part, which is going to be the second video, that's going to be talking about heating effect of current. And then going to talk about electric power. Electric power is going to include how to calculate your electric bills. When you get your electric bills, you can check whether it is accurate enough and valid enough. We're going to take a live example of an electric bill in the second part. So let us move forward. Let's clear the screen. So what is electric current? Electric current क्या होती है? When you get a shock, you tremble. You get a shock, right? You tremble. Your body starts shaking. Why? Because charges in your body start moving. They start vibrating. They start taking some direction, right? Due to which the current flow is possible. That is what is current. Now, what is the definition of current? Let us see. Okay. Definition of current is the amount of charge flowing through a particular area of a conductor. It's the amount of charge flowing through a particular area of a conductor in a given time. Let's see if I can make this bigger. There's no option to, yeah, I can make it bigger, line width, okay. And this is the selection, okay, fine. Flow in a particular area of a conductor in a unit time is called as the current. When charges start flowing into your body due to a shock, that is the current flowing into your body. Same way, you can imagine yourself as a conductor. And in the conductor, all the charges within the conductor start vibrating, start colliding, due to which they get a particular direction finally, due to some external force. We're going to see that next. And due to that external force, the charges start moving, which causes the flow of current. And the flow of current, a particular aspect of flow of current is that it flows along the positive charge, but it opposes the negative charge, which is the electrons. What is one electron charge? The charge of one electron is minus 1.6 into 10 raised to power of minus 19 coulomb, right? Then a few two conversions you need to remember. The first conversion is 1 milliamp is equal to 10 raised to power of minus 3 ampere, and then microampere is basically 10 raised to power of minus 6 ampere. And how is it measured? The current is measured using the ammeter. So let's see. This is the ammeter. This is the old meter, very, very old. The modern ammeters are usually nowadays coming as multimeter, where you can measure current also, resistance also, you can measure voltage also. I'm going to show it to you in some time. I have it behind on my desk. And we have this now the circuit here. In this circuit, this is the electrons are flowing towards the positive terminal. The positive terminal is attracting the electron, is attracting the negative charge. And because of this attraction, because of the attraction of the electron, the positive charges flow from in the ultra direction. That means the current starts flowing in the direction of the positive charge. Right? You see here, if the electrons are flowing this way, then the current flows in the opposite direction. So now let us see the formula. Let us see how to represent this current. If the net charge is taken as Q, which is flowing across any cross-sectional area of a conductor, and this flow is measured in a unit time called say T, then the current is given as I is equal to net charge by the unit time. I'll mark it here for you. Current is net charge by unit time. And net charge is measured in coulombs. Net charge is measured in coulombs. Time is in time. You have to take it in the respective SI units, whether it may be hours or seconds. And then current is in amperes. You have to be careful here to convert. If it is given in milliamp, then it convert to amperes, which is 10 raised to the power of minus 3 amp. Then microamperes has to be converted to 10 raised to the power of minus 6 amperes. Right? So I'll clear this on the screen. All this goes. We go to our next point. Okay, it's a graphical representation. You see here the battery is creating a charge. It's a power machine. It pushes the charges. It pushes its charges through the wire, due to which the bulb can finally light due to the current, due to the charges flowing into the wire. Okay? Current is given by charge by time. Next, let us see a problem. Let us solve some problems. Now here we have current I of 3 amperes is flowing through a wire of, for 4 minutes. Then it is asking, find the total charge that passes through the wire in this time. What is given? Let us mark what is given. Current is given at 3 amperes, then time is given in 4 minutes. Right? These minutes have to be converted to seconds, and then we need to find the charge. So let us try to solve this now. Please take some time and solve in 1-2 minutes, 1-2 seconds. Okay, let me solve it now for you. Step-by-step solution. First solution is we need to find the first step is basically we need to identify the formula. Which formula to apply based on what is given. So charge is given and time is given. So that means we need to use the I is equal to charge by time formula. So by rearranging this, you need to find the total charge equal to current into time. Time is converted into seconds, and then finally you get the charge, which is 720 coulomb. This is your final answer. Let's clear the content. Next question. What is an electric circuit? Can you take 1-2 minutes, write it down? Or you can fast forward it. Okay, let me solve it anyway, because anyway, you're going to fast forward. So, final answer, an electric circuit is a closed conducting part that allows the current to flow. The electric circuit is a closed conducting part. That means there is no open ends in the circuit. You see here the circuit here, the battery is connected to a wire, and that wire is connected to a resistor, and the other end of the wire is connected to the negative terminal of the battery. So basically, you see there is no open ends. It's a closed loop, closed conducting circuit is called as a electric circuit. Okay. Next, electric potential difference. What is electric potential difference? We studied current. Now current is caused due to some potential difference. Okay. So now how does water flow from your tank? ऊपर से टंकी से जो पानी नल पे आता है, how does it flow? Due to the pressure difference. At high tank, it's at high pressure, and the tap is at low pressure. So the high pressure water comes to the low pressure tap, right? You see here, water is flowing, gushing out of the tank from a high to low. Or you can see a waterfall from a high altitude, it goes to a low altitude due to the pressure difference. Now, in a copper wire also, due to the same pressure difference caused, that is why the current flows. No, there is no pressure difference here, but there is electrical pressure. And the electrical pressure is caused due to the potential difference. Potential difference because for the positive terminal of the battery and the negative terminal. One is the high potential and other is the low potential. That is why due to this potential difference across the battery, the current flow is made possible. Right? So if you see here, we have taken this sample circuit here. We have a battery charger here. This battery charger is connected to any other battery which is not having any charge. What is it? Not having any charge. This battery here is having high charge, and the battery on the other side is not having any charge. So we connect it to a high charging battery. Then what happens? Potential difference is created. Due to potential difference between the positive and negative terminal, current flow is possible and the charging of the other battery takes place. Instead of this other battery, you can imagine a copper wire there. The copper wire is put there. Then the flow of current will take place from the positive to negative terminal. Now you have to use a resistance so that the battery doesn't get short circuited. Okay. So potential difference is measured between 2 points. It is measured between 2 points. And how is it measured? It is actually the work done. The battery does some work to carry, it does some work to move some charges, some unit of charges from one point to the other. एक पॉइंट से दूसरे पॉइंट को चार्जेस लेके जाने के लिए बैटरी काम करती है. So that work done between the two ends of the battery to take the charge from one point to the other is called as the potential difference, right? The cell expends its chemical energy to give current into the circuit. And how is it measured? It is measured by work done by charge. And if you want to measure 1 volt, then it is measured of to do 1 joule of work to carry 1 joule of work is done to carry 1 unit coulomb charge from one end to the other. Okay. And how is it measured? It is measured using a voltmeter. It is always connected in parallel between the two ends. The ammeter instead of voltmeter. The old ones. I'll show you the newest one, multimeter. Okay, now that we have done this potential difference, we have understood the potential difference. Let's see what we have in our next slide. We'll clear this. So you see here, the battery which was having full charge is actually getting discharged. It expends its energy to move its charges from a high potential to a low potential initially. So the low potential becomes high potential next, right? Due to the movement of the charge, the battery loses all its energy, and hence all the energy is given to the other point, which is point B, which can be a bulb which gets ignited, or some resistance, or some heater, anything. Okay, the work done in joules by charge. Let's proceed. We'll see some problem. Now here, given here is a charge of 2 coulomb. It is moving through a potential difference of 12 volt. What is it asking? It is asking the work done in moving the charge. So let us see what is given. Let us mark what is given. Charge is given, 2 coulomb. Potential difference is given. So we use the potential difference formula to find the work done, right? V is equal to work done by charge. So let us see the solution now. The first step is to identify the formula, which is it is rearranged formula. Work done is calculated as charge into voltage, and we are substituting this. We substitute charge as 2 coulomb. Charge of 2 coulomb. We take this is the charge 2 coulomb. 2 coulomb is here, right? And then we take the voltage. Voltage of 12 volt is replaced in V. We replace here 12 volts, and finally we get 24 joules as your answer. Your final answer. Okay. This means that 24 joules of energy is required to move 2 coulomb charge from positive terminal battery of 12 volts to the other terminal battery negative side. Okay. So let's proceed further. This is how the circuit diagram looks. We can have a look. So the electrons move in the opposite direction to the current flow. Next, let me clear all this. So circuit symbol, this I have taken from your NCERT book. This is directly from your NCERT book. An electric cell. These are the various symbols you need to remember so that you can solve problems. Okay. So what is an electric cell? Let us see. We'll take a color, a different color this time. Can select a different color. Electric cell, the symbol is Bada Danda positive and Chota Danda negative. Chota Danda negative. This is Chota Danda. And the battery is a combination of cells. It's a combination of cells. 1 cell, 2 cell, 3 cell. Bada Danda, Chota Danda, Bada Danda, Chota Danda, Bada Danda, Chota Danda. Okay. Then if a plug is meant to be open, then we show it open here. There is no dot in between. If you want to show it closed, then you see a dot here. Wire joined. If it is a joining wire, then it is shown as a dot here. This is a joint, right? These three wires are joined by this single dot. If you want to show that a wire is not joined, it is jumping over the other, then it is shown as a loop. An electric bulb is shown like this, like a W, ulta W, or a bulb itself. Resistance R is like a wave, like a water wave. And then a variable resistance and rheostat, that is a variable the resistance where you can adjust the current. It is shown like with an arrow or a downward arrow. Okay, ammeter and voltmeter. These are all the symbols you need to remember. It is directly taken from the NCERT book and shown here. Okay. Okay, we clear this. Now we see Ohm's law. What is Ohm's law? Ohm's law. Ohm's law is defined as the potential difference. The potential difference across the metallic wire is directly proportional to the current flowing through it, and provided the temperature remains same. What is it? What is it? It is the Ohm's law states that the potential difference across the metallic wire in an electric circuit is proportional to the current flowing through it, provided that the temperature remains same. Okay, this is Ohm's law. That means potential difference is proportional to the current flowing. That means how much the voltage, that much the current. Lower the voltage, lower the current. Higher the voltage, higher the current. Now we have to remove the proportionality sign. So to remove the proportionality sign, the wire, the circuit will have some resistance, right? The proportionality sign will then be removed by the resistor. The V is equal to IR. Voltage is V, I is current, R is resistance. So this is Ohm's law. Ohm's law says that the potential difference, that is the electric pressure applied by the battery, which is defined as V, voltage, is directly proportional to the current available into the circuit. And this current can be opposed. The current can be opposed by the resistor. The current can be opposed by the resistor. Like the higher the resistor, the bulb will become dimmer. And lower the resistor, the bulb will start glowing wonderfully, provided it meets the required parameters. Okay, it should not be too large, should not be too high current that the bulb may just blast off, and it should be too low that the bulb will just appear dim. It should be bright enough for you to see the things around, right? So V is equal to IR, or when you rearrange it, you get current is equal to voltage by resistance. Okay, these are some spelling mistakes. You can ignore this. You can ignore this. Okay, so let's move forward. So this is rearranged. I can be written as voltage by resistance. So I is inversely proportional to resistance. If resistance doubles, then current. If resistance doubles, means current has to reduce. So current will decrease by half. Okay. Now we have something called as variable resistance. Variable resistance can control the flow of current in the circuit without changing the voltage source. That means without changing the voltage source, you can control the current. You can regulate the current. This is called as a variable resistance or rheostat. We have seen how the rheostat is represented. It is represented with a wavy resistor followed by arrow, right? Upward arrow, slanting arrow. Okay. So let us move forward now. We'll wipe it off. We'll wipe this extra stuff. So this is a graph of current versus voltage versus current. That is Ohm's law representation. Voltage is proportional to current. And that is given by slope, which is represented by R. Slope is represented by R. Here is given by voltage by current. Voltage is on the y-axis. Slope is basically y-axis by x-axis reading, right? So voltage by current. Here, if you take this particular cross point, you get voltage as 6 volts multiplied by, it has to be divided by, this is a division. क्या क्या गलती होती है? The division by 3 and you will get 2 ohm as a resistance. Okay. Ohmic relationship is a linear relationship. Okay, now that we have understood the Ohm's law in a graphical representation, let us see, let us clear this off. and then move to our next part, which is factors on which resistance is dependent. What are the factors on which resistance is dependent? Now, a group of people met together, sat together, and they did some experiment using an ammeter and a resistor in a closed circuit. And what they found? That the ammeter is given here. The ammeter reading showed half the reading when the length of the wire, if the length of the wire was L, it was double. The length of the wire was double. Then what happened to the resistance? Resistance increased. So what happened here? Resistance increased. Length became 2L. Then resistance also increased. Right? That is why current reduced. Resistance increase means current has to reduce. That's why the ammeter showed a lesser reading. Ammeter showed a lesser reading. That means here we can deduce that length is proportional to resistance. Right? We can deduce this. So the next another aspect which they found is that the ammeter reading increased. What happened to the ammeter reading? It increased when a thicker wire was taken. That means the area, cross-sectional area of the wire increased, but the length remains same. This implies that the resistance decreased, right? The current can increase. That means the ammeter current reading increased, means the resistance was reduced. That means when the area increases, the resistance reduces. That means radius, I'm saying radius all the time. R for radius also, but R for resistance also. Resistance is inversely proportional to the cross-sectional area. Right? Resistance is inversely proportional to the cross-sectional areas. Here R, resistance, is directly proportional to length, inversely proportional to area, and as we already know, current is inversely proportional to resistance. Now, we see that resistance depends on the length, area, inversely proportional to area, and the nature of the material. The nature of the material can be a copper, it can be aluminum, it can be iron, it can be anything. It can be an alloy or it can be a non-conductor itself, right? And this material, whether it is copper, iron, okay, these have some resistivity. This resistivity is called as rho. It's called as the electrical resistivity and depends on the material. It depends on the material of the conductor. Be careful here between resistance and resistivity. Resistivity depends on material. Resistance doesn't depend on material directly. Sorry, resistance depends on the nature of material, but resistivity doesn't depend on the shape and size of the material. Okay. So we see here, it depends on the material. Resistivity depends on material and temperature. It doesn't depend on length, it doesn't depend on area, shape, or size. Okay. So next, resistivity order. There is order of resistivity. There are three types of materials. One is conductors, one is semiconductors, and third are insulators. So when you see metals have the least resistivity, followed by alloys, and then insulators have the highest resistivity. So metals and alloys have a resistivity range of 10 raised to the power of -8 to 10 raised to the power of -6 ohm meter. That means they are conducive to electricity. They allow current to flow. Okay. And then insulators, they tell current wait there only, do not flow. That's why you need to wear rubber chappals when you touch any electrical circuit, so that you become like an open circuit that doesn't allow current to flow. That means you will not start shaking when the current flows. Okay. Always wear rubber chappals, not steel chappals. Okay. So then we have conductors. Conductors are called copper and aluminum. Then we have alloys, nichrome, and insulators like rubber, glass, paper, or diamond. It will be expensive to stand over diamond. I know what you think. Okay. Or you can keep large sheets of newspaper. It's cheaper, right? Now, rho is given by the formula resistance into cross-sectional area divided by the length of the wire. Okay. So now that we have understood about the factors on which resistance depends, let us move on. Let us clear this stuff. Let us move on. So as we see here, Resistivity, not resistance. Resistivity depends on the material. Okay, depends on the type of the material. For the same material, irrespective of shape and size and area, resistivity remains same. Resistance changes due to resistance changes by length, area, or nature. Nature means resistivity. You see here, same material, same resistivity, same material, same resistivity. Right? You can ignore this formula for now. We've already seen the formula RA by L actually. The L is missing from here. Okay. Property of the material independent of shape and size. And these are the different materials which we have taken. This is taken from your NCERT book. This you can try to remember some of them. Like silver is 1.6, 1.62 is copper, and followed in that order. You can remember manganese, which is having 1.84, quite moderate kind of conductivity. 1.6 silver has the least resistivity actually. Least resistivity. That means silver allows current to flow very efficiently compared to copper. And copper is a good replacement for silver because copper is slightly cheaper than silver. Oh, let me buy copper and keep instead of silver. Okay, let's move forward. Let's rub out this extra markings. Let's see a problem. So what is given in this problem? Let us read it out. There are two parts of the problem, A problem and B problem. In the first part of the problem, it is asking how much. It is asking about current. It is asking about current. And what is given? Electric bulb connected to 220 volt source. And the resistance of the bulb is given as 1200 ohm. And the second part, the same resistor, same voltage is taken, and it is replaced by a heater coil with a different resistance. So how do you solve it? Can you solve it quickly? Take 5 seconds. 1, 2, 3, 4, 5. Okay, let me solve it now for you. This is a step-by-step solution. The formula to be used is Ohm's law, I is equal to V upon R. And then for a bulb, given voltage is 220 volt. For resistance is given. Then you find out the current. Current is basically voltage by resistance. You will get 0.183 amperes. And then you have, now you have a heater coil with a different resistance, right? Voltage is same, resistance is different. So you'll get 2.2 ampere. So basically, if you see here from this example, resistance was 1200 for bulb. So current was very less. That means meeting his particular requirements of current, bulb current requirement. Heater coil needs huge current, large current. That's why it has a slightly reduced resistance. So large amount of current can flow through it. Okay. Final answer, what is given here? 0.183 ampere and 2.2 ampere. Next, we have, let me remove these markings. Another problem. Nice problem. Let us see what is given in this problem now. The resistance of a metal wire of length. Length is 1 meter. Resistance is 26 ohm at 20 degrees Celsius. Diameter is given. Diameter of the wire is given. We need the radius most of the time to find the area. And it is asking for resistivity. Resistivity formula we already know. Then it is asking based on resistivity to guess which material the wire is of. So let us solve this now. So the formula to be used is R is equal to rho L by A. So now where R is resistance, rho is resistivity, L is length, A is cross-sectional area. Now we calculate. First we check what is given. The diameter is given, so we measure the area we measure the radius, which is half the diameter, to calculate the area. Once we find the area, then we rearrange for resistivity and we put all the values here. R is given. R, which is resistance, is given. Right? R is 26 ohm. 26 ohm is put here. Area is calculated in the previous step, 7.07. It is put here in the formula. And it is divided by length. Length is 1 meter. 1 meter is put here. And proceeding forward, we then get the value of 1.84. If you remember, this value was for manganese. Manganese. Right, manganese. No, I already knew that. I'm pretending to, I don't know. Okay, let us wipe this off and then proceed to the next part of it. Combination of registers. Registers can be used in combination, in different type of combinations. There are two combinations which we are going to study here. Okay. Resistance, as you know, is the opposition to the current. And how effectively we can oppose, it will be given by how we form the composition of resistance. Okay, whether it's a series combination or a parallel combination, these are the only two combinations you have in 10th standard. Larger the resistance, more difficult for the current to flow. That means rubber has high resistance and hence a poor conductor. Or if you use resistance in series or parallel, that will also give you equivalent resistance. And we'll see in which case the resistance becomes high, in which case the resistance becomes low. Okay. So here we have a series resistor. We're going to study first a series combination resistor. So how do we form the series combination? This is how the series combination is formed. As you see here, we take resistor 1. We take resistor 1 and connect it to the left hand of resistor 2. Right? Right hand of resistor 1. Right hand of resistor 1 is connected to left hand of resistor 2. And likewise, right hand of resistor 2 is connected to left hand of resistor 3. And the other hands are connected to the battery. This is how a series combination is going to look like. If you want to visualize it, then the current which flows, let me show it in form of current also. So it will become good for you to understand. I'll take an arrow here which shows the current in red. The current which flows is flowing to this junction, which is this point, and this point is connected to voltmeter. This current which flows is going to be the same across all the resistors. It cannot break, right? The current cannot divide here. But in reality, it divides here because very minimal amount of current flows to the voltmeter. Voltmeter is very high resistance. It doesn't allow current to flow through it. That's why it can measure the voltage. It doesn't allow the current to flow through it. Remember, an ideal voltmeter doesn't allow current to flow through it. So if it doesn't allow current, it means that the same current is going. There is no junction further. And the same current I is flowing to all the resistors. So that is why it's called a series connection. You can see here the battery going to resistor 1, 2, 3. Right? There is no other junction. There is no other further junction which appears across these resistors. If there was a further another wire here, there was another wire here, and another resistor here, then the current would get divided. Then it would have been a parallel circuit. We're going to see that next. Now, in a series combination, current remains same. What remains same? Current is same. So because current is same, we can measure the potential drop across each resistor. And because V becomes equal to current, which is the same current into R1 for the first resistance. Then for the second resistance, it will become V1. Then voltage V2 across the other resistor will become I into current into resistor 2. And the third one, V3 will become equal to current into R3. Right? This is the voltage measured across each of the resistors. Arey hato. So as you see here, voltage is different. As you see here, voltage is different across each resistor, so the current is same. That's why we can deduce that total voltage can be given as V1 plus V2 plus V3. V1 plus V2 plus V3. And current is same across all the resistors. So now let us go and let us see parallel circuit. See the parallel circuit. In parallel circuit, what do you see? The left and right hand of all the resistors are connected to the left hand, right hand of other resistors, right? This left hand is connected to left hand of R2, is also connected to left hand of R2. Similarly, right hand is connected to right hand of R2, and right hand of R2 is connected to right hand of R3. That means what happens? Now the current which flows gets split. If the current is flowing at the green line, here current is flowing, then it gets split into three parts. It gets split into three parts. One flowing like this and other flowing like this. Sorry, two parts. Right? Will flow like this, and then another current will flow here. Another current will flow here. Right? So R1 will have a different current, R2 will have a different current, R3 will have a different current. Then finally the current will come out here and get back as I only. The same current I will get added at this junction. This is a parallel connection, wherein the voltage across all the resistors remains same, but current changes this time. What changes? Current change. Current is different, voltage is same. In a parallel circuit, we can deduce that current is a summation of current flowing through each of the resistor. Okay, hence the equivalent resistance is a reciprocal. It's a reciprocal of all the other resistors. That means the parallel circuit offers the least resistance. It's the most efficient circuit, right? Because the energy consumption is efficient because of least resistance. And the total resistance, equivalent resistance of a parallel is smaller than the lowest resistance in the circuit. Okay? And hence, we will get to see what are the advantages of parallel and series connection. So let us clear this and move ahead. We have a problem. Fantastic. What is given in this problem? What is given? An electric lamp. Wow. It's having a resistance 20 ohm, which is 20 ohm electric lamp. And a conductor is taken off, basically a resistance of 4 ohm, and connected to a battery of 6 volt, a 6 volt battery. It is asking total resistance of circuit. Resistance of circuit is a summation of both the resistors, right? It's a series connection because left and right hand of the bulb is not connected to the left and right of the resistor directly, right? It is connected to another equipment, which is the battery, right? We cannot connect it. We cannot consider that as a parallel. So it's a series because the right of the bulb connects to the left of the resistor. So the summation of this will give the total resistance. The current through the circuit will be given by the voltage divided by the equivalent resistance, with the sum of the resistors. And the potential difference across the lamp will then be given by whatever current you get will be multiplied by the individual resistors. So let us see the solution quickly. Given is resistance of the lamp is given, conductor resistance is given, battery voltage is given. It's a series connection. And total resistance is summation of the resistance, which you get 24. So we deduce using Ohm's law what we deduce by Ohm's law, we deduce the current, right? We'll get a 0.25. Voltage is 6, 24 is the resistance. The potential difference across each component will be now the same current I multiplied by the individual resistance, right? Across the lamp, it will be voltage will be current into the resistance of the lamp. Current into resistance of the lamp. Resistance of the lamp will give 5 volt. The next part, across the conductor will be V2. V2 will be the same current 0.25. 0.25 is taken here for V2 also, multiplied by the resistance of the conductor, which is 1 volt. This is the summary of the answers. Clear this? We're coming to a closure almost. Oh, no, we have another problem. In the parallel circuit given here, the resistance values are given. You have to solve it. Try solving it quickly. The resistance is given as 5, 10, and 30. This is 5, this is 10, and this is 30. Connected to a 12 volt battery. For parallel connection, voltage is same, current changes because the joints are different now. There is a joint here. Because there is a joint here, current will split. So the current is different, and hence it is a parallel connection. So what is the current through each resistor? What is the total current? And then it is asking total resistance. Try solving it in a minute. Okay, anyway, we're going to fast forward it if I give a minute. So let me anyway give the solution. Okay, to each resistor using Ohm's law, you find the current. And current for R1 is given by voltage divided by the its own resistance, which is R1. And similarly for R2, similarly for R3, we take the individual resistors. The total current will be the summation of all the currents, I1 plus I2 plus I3, which is 4 amp. And total circuit resistance is ulta wala equivalent resistance, which is 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3, which will give 1 by 3. So R equivalent is 3. Here you see that the equivalent resistance is smaller than the smallest resistance in the circuit. That means 5 ohm. 5 ohm is the smallest resistance, but the equivalent resistance is even more smaller, offering a much better circuit representation, much better circuit used in ohms. So let me clear this. So now that we have seen series and parallel, let us see what are the advantages of parallel and series. So as we have seen, for parallel we can get specific current in each of the circuits. That means each resistor can work on its own. If the resistance is replaced by a device, then every device can become independent of the entire circuit. That means if one device fails in a parallel connection, the other device will still continue to work. But in a series connection, if one device breaks, if one device fails, then it will stop working. We have a series connection like this. This is one resistor, for example. So example, and now this particular appliance, if this was an appliance here, if this appliance breaks down, then this circuit will become open, right? It will become like an open circuit. It will be one line here. And if this is another device which was connected in a circuit with a battery, then because it is open here, there will be no current flowing in the circuit because in a series connection. But in a parallel connection, even if one resistance breaks, or even if one device or appliance stops working, then the other appliance will still continue to work. Just taking for an example, just to illustrate, this is a battery here, and if this circuit breaks now, so what will happen? In this circuit, there will be no current flowing. In this circuit, there will be no current flowing. But still, the wires are joining, right? The circuit is still complete in the other device. So it will continue to flow in the top device. So that is the benefit of parallel connection. So the second advantage is independent current needs. Now each device will have a different current requirement. A bulb will have a different requirement. Refrigerator will have a different requirement. You can connect them in series because the same current will flow for everybody. One other device will blast. So that's why you take a parallel connection, right? So here you get an independent current need. Then equivalent resistance also is reduced, offering a least resistance. It offers a least resistance. Hence, the energy consumption is more efficient. Right? This was the final topic. We'll do a quick recap now. We have studied about electricity. We have seen electric body is electric current. Electric current is the amount of charge flowing from a particular area in unit time. I'll just mark it as well, whatever I'm going through. Amount of charge flowing through unit time, right? It is measured using a ammeter. And then we have seen the formula for current basis, the charge flowing and the time. Then we've seen electric potential difference. We have seen that electric potential difference is the work done to carry one unit charge from one place to another place. And it is measured using a voltmeter. Then we studied the formula for voltmeter, which is the work done by total charge carried from one point to the other. Then we've seen Ohm's law, which is the proportionality sign of, which is the proportionality law, which is potential difference is proportional to the current in the circuit, which is represented as V is equal to IR. V is equal to voltage is equal to current into resistance. Then we saw about resistance. In resistance, we saw that the property of the conductor is to resist the flow of the current. It depends on length, area, and material. And it's given by the formula R is equal to rho L by A. That means resistance is directly proportional to length and inversely proportional to area and directly proportional to its material, nature of the material. And then we saw two types of circuit, combination of resistance, parallel combination resistance, and then we saw series combination resistance. These are the two formulas which we have studied. And then we have seen resistivity. In resistivity, we saw depends on the material. That means conductors allow the current to flow. Insulators say no, don't allow. And semiconductors allow some, don't allow sometimes. Okay. And then finally, we need to see heating effect of the current and electric power, which we are going to see now next session. So with this, we conclude our today's session on electricity. So kindly like and subscribe if you have enjoyed this video. If you have found this video interesting, if you have found this video, understandable. Physics is all about concepts and understanding the concepts. So if you have any difficulty, you can write to me. Thank you.